Sure it is. Okay. Hello, everybody. My name is Jim Hester. I'm a software engineer at RStudio, and I'm going to be talking today about gluing strings to data with the glue package. So gluing strings, or sometimes called string interpolation, is really everywhere. So you'll see this in Excel with like the concatenate function, where you're taking two columns and concatenating them together. You can see it in Bash with the $ syntax to retrieve the value of a variable, or in Python with the format method, or down at the bottom here what's called an F string. It's fairly new in Python 3.6. So there's a couple different ways to insert values into strings in Python. And I mentioned the F string syntax specifically because the glue package uses a very similar syntax in how we do this. But this is the point of this slide is basically this is a very common operation. It's used in a wide variety of programming languages. So it's a really common problem. So I kind of feel like gluing strings in R is fairly painful. So you basically have two built-in ways to do this, two functions to do this. You can use paste or paste 0. The issue there is if you're combining string literals like the inventory apples and bananas here with values, the variables apples and bananas, then you have to quote the string literals and then insert the values with commas, and it gets to be very heavy syntax. The other alternative is sprintf, which has heritage in like C languages. Basically, what this does is you have a string, you have special syntax to insert values into that string, and then you give all of the values that you would like to insert at the end of the function call. The issue here is there's a disconnect between there's a disconnect between the values and the insertion points. So you don't, because the syntax doesn't have a name or number, there's not an easy, it's fairly easy to have a mismatch between the place that you would like to insert it and the value that you're inserting, especially as you're trying to insert more and more values into the same sprintf call. So glue is a solution to this problem. So here we're basically doing the same thing. Use the syntax with the curly braces, and whatever's inside the curly braces is evaluated, and then the value is inserted at that point in the string. So you can see this is sort of a self-documenting format. So we're inserting the apples and the bananas, and then we also you can do arbitrary expressions, so it's not just interpreting a specific variable. You also can have an arbitrary expression, such as apples plus bananas. So then you can see we get the same output as the other two examples. So glue is really designed for users using R scripts. So this is showing an example using dplyr with the Motor Trend Cars dataset. And so here I'm basically just grouping the dataset by cylinder and then creating a description. So this is just a simple text description of each group, where the text description is the average number or the average horsepower of the group, the standard deviation, and the number of cars in the group. So the other feature of glue that this is showing is you can, in the call to the glue function, you can define additional arguments, and those arguments are then available for use in the glue string. So these I don't actually have to make a new variable for this average standard deviation and n those arguments, but I can still use those in my glue string. So this is a nice way. So rather than having to embed this code into the string, and maybe which would make it harder to read in some cases, you can do this to keep your code as code. And you see that we get a tibble here with each of the groups and then the string that we created. But glue is also designed to be used in packages. So some reasons for this. Reasons is good for use in packages. It has zero extra dependencies. The only thing glue depends on is itself. It's also tested all the way back to R3.1, so you can use it in pretty much all of the versions of R that you would use these days. It's also customizable, so and I'll go into that in a little bit more detail, but package authors can tailor the function to do exactly what they want it to do in their package. It's also reasonably fast compared to alternatives. So one example of how this could be used in a package, here I'm creating a helper function called abort. It basically just calls the stop function, which is in base R, to stop execution and throw an error, along with the glue function. And what this allows you to do is, in this case, I'm doing an HTTP request and checking that the content type of the response is equal to what I expect it to be. And if it's not, then I'm going to throw an error. And it's really easy to make useful error messages. And this actually, I think, is really helpful as a package author, because if you can make the overhead to creating an error message lower, you're more inclined to make more useful error messages for your users. So if you're writing a package, I think this is a really good way to improve your error messaging. So glue is also customizable, I mentioned. So one way in which that is the case, the glue function takes an open and close argument. And this allows you to actually change the delimiters that are used around the variables you want to glue into your string. You can actually change these to any arbitrary strings. So in this case, I'm constructing JSON strings, and since JSON has a lot of curly braces in its syntax, you don't really want to use curly braces as your glue delimiter, so I'm going to change them to the greater than and less than sign, and then we can use that instead. So here we're just inserting apples and bananas into here. Then we can just parse that JSON to verify that we constructed a valid JSON, and you see you get the values you'd expect. So the other way you can customize glue, and the more powerful way, is using transformers. So there's this transformer argument that basically takes a function and allows you to customize how glue evaluates the text within the delimiters, both before and after evaluating the code within it. So you can modify the R code before you evaluate it, or you can do something to the value afterwards. So in this case, I'm evaluating the code and then shell coding whatever the value ends up being. And you can just make a very simple helper function that takes that transformer and then use that. So here we have a file name, and then we're creating a command. So we're just doing cat and then the file name, and this will automatically shell code the file name for you. So this is a simple example, but it shows you it's really easy to make robust quoting functions based on this technique. So you can also, another example is, let's say you like using sprintf, and sprintf gives you a very nice, concise way to format floating point numbers. So let's say you want to restrict the number of digits after the decimal place to a specific number. And you want that in your glue function. So this gives you a transformer that allows you to include that syntax. So if you have this colon and then some text afterwards, that is basically passed to sprintf. If not, then it just evaluates the value as it would normally. So using this, again, we define a new helper function, pass it that transformer, and then you can just call this helper. So here we're doing pi, but we're only restricting it to two decimal places after, or 2 digits after the decimal place. So that's an example of making a very concise formatting string. So you can do things like that. Another example of using transformers, here we're using the emo package to insert emojis into a string. So this is a fairly common way of defining an emoji in, I think like GitHub for instance has this, or maybe Twitter as well, that you use the colons to delimit the emoji, and then will be inserted. The other like extension here is I'm using a star to concatenate multiple emojis together. So basically, so this emo package has a find function that will find all the emojis that have a given name in their description or in the name, and then we can combine. So there's multiple that have hands, and then we combine all those together. Say many hands make light work. So this is another example of maybe not as practical, but you can do pretty interesting things with these transformers. So I mentioned glue is fast. So this is that's not working how I expect. Okay, so it's fast on single strings. So this is just a simple benchmark, basically the most trivial benchmark you could do, taking foo and adding bar to it. You can see so basically this might be too small to read, but glue is here. Here is sprintf and paste 0. So those are the two functions from base R. They're primitive functions implemented in C, so they're going to be very fast. They're basically the bottom bar of how you could do this. There's like a few other functions here implemented in other packages. For at least this case, glue, which do very similar things, string interpolation. At least in this case, glue is the fastest of the functions available in packages, but not as fast as sprintf and paste 0. If we then expand the benchmark, so before we were doing this only on one string, now we're basically doing the same thing, but instead of doing one string, we're doing 100,000 strings. And glue is vectorized, so the output here will be 100,000 foo bars. And in this case, glue is actually faster than sprintf and basically on par with paste 0. So we're constructing 100,000 strings in about 20 milliseconds. So it can actually do this fairly quickly. And compared to the functions in the other packages, it's a reasonable amount faster in this case. So why is glue fast? So all of the delimiter parsing is done in one pass in C code. So that is really usually not the thing that is the bottleneck. The performance is typically dominated by parsing the R code, so the R parser, and evaluating the R code. And then glue also uses paste 0 internally, so which is part of the reason it's never going to be faster than paste 0 because it uses paste 0. So. But if your code is still slow, take advantage of the vectorization in glue, and that if you can rework your problem to take advantage of that. So for instance, instead of using glue with like an inner for loop, if you are able to use it in a vectorized way, then it will probably be much faster. And there's also a vignette on the glue website and in the package that has these benchmarks and a little bit more. So I'd encourage you to go there. So glue also contains more than just the glue function. So there's a glue data function. So this basically generalizes the glue function a little bit. So glue takes variables from your current environment and pastes them into strings. Glue data takes variables from any environment or list or data frame and lets you take the variables, glue the variables from that. So in this case, we're again looking at the motor trend cars data set, passing that to glue data, and then I can use the variables within that data frame directly in my glue data statement. So the cylinder variable is only in that empty cars data set, and the horsepower for the same thing. And this is also showing the vectorization of glue and glue data. So I can run over that entire data set with one call to glue data, and you see it vectorizes through all of the arguments. So there's a collapse function in the glue package. So this basically does the same thing as paste with the collapse argument. It has a few more niceties that make it a little nicer to use. So there's a sep argument to control the separator between the elements. There's a width argument which restricts the output to a specified width and truncates it if it goes beyond that. So this is really useful in error messages, for instance, if you want to print as many of the elements as you can fit on like your screen width. This is a really nice feature. And lastly, so there's a few other helper functions like backtick and single quote and double quote to make quoting elements easy, and you can pass those into your collapse function, as well as there's a last argument, and basically what this does is change the separator for the last two elements, which makes it nice to, if you want to do a big list like this and then add a different separator for the last two elements, which again is very nice in things like error messages. Another function in the glue package, which is basically just glue with a custom transformer, but it's complicated enough that I felt, and also useful enough that we decided to make it its own function. It's called glue SQL, and basically what this does is automatically quotes SQL strings for you. So if you're generating SQL, this will handle the quoting of both like identifiers as well as values, and it also returns the data as a SQL object, which helps prevent things like SQL injection in some cases. So to illustrate this, here I'm defining a simple connection to an SQLite in-memory database, then creating an ID with a schema and table, and then I can create a simple select statement based on this, and what I pass as the table identifier is just the table, the variable, and this is then quoted appropriately based on the quoting rules for the whatever backend you pass in. And then again the values, and again I'm using the star syntax to indicate multiple values. So we're inserting multiple values that are quoted and collapsed appropriately for whatever database backend you're using. And this will also, so in this case I'm passing a string in this in statement, but if I instead passed numbers, then those would not be quoted, and you'd get the correct syntax for that case. So glue is popular, maybe? So this is from our documentation.org, which is a DataCamp product, our website. And basically so you can see glue is like the #1 most downloaded package by this metric. However, I pretty much guarantee this is not correct. I think very unlikely the people are doing install.packages glue the most out of any package. I think what's happening is glue is a dependency of dplyr and stringr and tidyr, and whatever method they're using to detect direct downloads is not working correctly. So, but because it is this dependency, it is actually used quite a lot. So this weekly downloads is coming from the RStudio CRAN mirror. So those are actually valid numbers. They're just the raw downloads for every package. And there's over 100,000 downloads of the glue package per week. So it's definitely widely used. It's used in these packages, so if you have them loaded, you probably already have glue on your system. So you might as well use it, I guess. So yeah, try it out. It's on CRAN. Install that package as glue. You can go to the website, glue.tidyverse.org, and happy to answer any questions. Thanks. Yes.
You were combining collapse and glue. Saw your collapsing had no interpolation in it. So is collapse accept interpolation, or do you need to combine the two?
So yeah, all collapse does is take. It doesn't do any interpolation. So basically, you would use collapse within a glue statement. You would use it within the braces. So if you had, I can just like show you. Hold on. Is that big enough? So if you have foo, you just do something like that. Yeah. And then I think I have too many quotes. Oh, right. And I don't have glue loaded, but yeah, so basically that you'd use it like that. Or you can put this in a variable or something.
So the way would be to vectorize glue after collapse, right?
Yeah, right. Or you could do that, right? So you could do. I have to like not quote these, but yeah, the other way, I guess, right? You could do this, and then pass that to collapse. Yeah, same idea. Yeah, so you can basically use them whichever way. Yeah, but that's a good question. Anybody else?
I see it has an environment
Yeah.
parameter. Does it have the same scoping rules that you would expect in base or SPNF for lexical scope?
Yeah, so it should primarily be lexical scope. It is lexical scope. I mean, the default to the environment parameter is parent frame. So it should be lexical scope. Mainly the only time you ever have to use the environment parameter is in lapply when you're calling it within an lapply function.
Would not be the same.
Yeah, sure.
Right?
Yeah,
So
right. Or if you
thing,
want, yeah,
like,
that's why we have an argument, I guess, is in cases where you don't want parent frame to be, if you want your environment to be something else. Yeah. But primarily, for the most part, you don't end up having to change that much.
unless you were using it like an enclosure that was returned by something, and then
Yeah.
it could be a
Right.
little
Yeah.
janky.
Yeah. All right. Thank you, everybody.